When it comes to file system forensics, there are a ton of resources online, in print, journals, all sorts of material that's aimed to help break down these complex structures and give you the ability to navigate them with confidence. Now, I just want to take a few moments to explain and kind of demonstrate and take a look at some of the different types of ways that this online documentation can be presented, because it's very important that if something is typically referenced as 1C0H, that you can also be confident in recognizing that 0x1C0 is actually the same location. It's just represented a little bit differently. So we're going to take a look at this using the master boot record Wikipedia page, which is popular. It's been around for a long time, and we're going to show you how it looks a little bit different than what we're dealing with in our textbooks, and also maybe some of the guides that are used in these walkthroughs. We're going to take a look at the structure of a modern standard master boot record, or MBR. Now, we can see here in our guide, as we look at this particular demonstration file system, or partition to be specific, our offsets, or where our locations, are different than what we've really seen in the past or what we've talked about in this course so far. Here is that it represents as hexadecimal 000, which is consistent, and it goes for the first 444 bytes, just as if we are continuing to work in our other materials. Let's take a look here at partition entry number 1, which starts, as we've covered before, at offset 1BE hex, or as this particular guide works it as HEX. This is also 0x1BE or 1BE lowercase h. It's very common that you could see this here. It's also possible that you could see this exact same thing if we changed our view to decimal. Some resources, particularly like our textbook, can start it off at offset decimal 446. These 4 pieces here all represent the same exact location. It's crazy. There's not really any one particular standard when it comes to documenting these types of structures. There's a number of different flavors that are out there, and it's up to you to kind of figure out which one works best for you, but also be flexible, because sometimes a lot of research went into understanding one type of a structure and it's written in one way, and you just have to be able to be flexible enough to understand and interpret this. We're at 1BEH. Now let's scroll down here to the layout of one 16-byte partition entry, because if we go back up just for a second and look here, we can see that we know that there are 16 bytes in a single partition entry, but there's no breakdown components within here. But yet in our previous work, we've been able to learn that there's a lot of really important structures in an individual partition entry. Look at the layout of one 16-byte partition entry. Let's see what we can find for how to navigate this really important structure. So when we're looking here, we can see that the offset bytes is in yet another different type of format. This one represents as 0 hex. Now, we know from our reading that to see the start of the first partition entry, we're supposed to be looking at offset 0x1BE or decimal 446. Either way is correct. But here it shows as 0. Now, why this shows as 0 is because this table, and it's very common that this approach is taken in these types of guides, is generic to all partition entries, not the first partition entry, not the second or third or fourth or extended or anything. It is specific to none of them, but yet specific to all of them in the same sense. It is generic, so that way you don't have to be hard-coded to 1BEH or 1BE hex. This same guide applies to the second, the third, the fourth, and however many number of partitions you have to deal with. And the same goes for the GUID partition table as well. It's in this type of a table, it is critical that you are positioned correctly in the very exact spot that you need to be in. Because failure to be in the exact spot, even 1 byte left or 1 byte right, makes a world of damage to your ability to properly interpret these types of structures. You have to be in the right spot at the right time every time to get it to work correctly, because there's only 16 bytes. So if you're off by left 1 or by right 1, it's wrecked, and that's a problem. So when you're looking at this guide, it counts when you see these types of guides and it says 0 or +1 or +4, it counts on you to be in that right spot. So let's get in that right spot here and go through a couple pieces for an example. Starting at 0 at the start, that's our boot flag. We covered this before. So starting at +1. Now when it says +1, it also goes by base 16, which means 0 through 9, A through F. So when it's +1, it means this is 0 and this is 1. So starting at +1 for a total length of 3 bytes is our starting CHS. Whoops. Here we go. My goodness. So that's +1. Now let's take a look at +4. So that means 0, 1, 2, 3, 4. That's +4. That's our location for a total length of 1 byte for our partition type. +5, it starts right here. Again, that's 0, 1, 2, 3, 4, 5. That's our ending CHS. Let's take a little bit further here. Let's skip down to +C, number of sectors in partition. So that will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, switching A, B, C. Remember 0 through 9, A through F, base 16, that's C. And then C for a total length of 4 bytes, bringing us all the way to the end. And if there was a second partition type entry in this MBR, that would be 0 for the second partition entry. And then we scroll back up to the top and start off at 0 with the boot flag section. So this was just a quick piece to kind of walk you through how to look at some of these different types of guides, give you some experience so that way, no matter if you see it as +0, 1BEH, 0x, 1BE, or decimal 446, you can be comfortable in your navigational capabilities and understanding where you are, where you need to be, and how to work with these guides to make your life a whole lot easier. Hope this helps.